In this video, we're going to start section 1.3, part 1. We're going to continue our work with solving equations, but this time we're going to be looking at equations that have variables on both sides. And so we're just going to add one little element to our plan here. And so if we look at this first example, negative 5 minus 2x equals 3 minus 3x, you'll notice, much like a couple of the story problems that we worked on, you will see that we have an equation with variables on both sides. And that just means we have to add one little extra element into our solving. And so let me zoom out a little bit here. And let me change the shape of this a little bit. 1 second. So really all this means is before we jump in, we want to do our first step is the same as before. We want to take a look at each side and see if there's any math that we can do. Can we do a distributive property? Can we add some x's together? Can we add some constants together? And in this example, no. Like each side is got things we can. There's nothing we can do, and so we move on to step 2. Step 2 is where we do our only different thing, and that is we want to get our variables on the same side. And it does not matter which side. There is kind of a way you can analyze it and make it easier on yourself, in my opinion. But you don't always have to move them to the left side or always move them to the right side. You can do it based on what you think will be easiest. So in this case, I think what I want to do is I want the 3x on this side, this minus 3x. I don't want it there. I want it to be gone. And so if we keep straight in our head the math that we're doing and don't get caught up in the moving word, right? We're not moving things, and I shouldn't even use the word move. What we're really doing is trying to make it disappear. And so I don't want a minus 3x here, but I want it all gone. I don't want just the 3 of it gone. I want the 3x gone. So some of you are going to have an inclination to want to divide by 3 to start, or to divide by 3x, because you're used to, hey, whenever that variable is there, we usually divide. But dividing by 3 would only serve to split the 3 off of the x. We don't want the 3 to go away. We want the whole thing to go away. So you need to retrain your brain to look at this critically and realize, I want this minus 3x to be gone. What's going to get rid of a minus 3x? A plus 3x. Not a division, not a multiplication, but the opposite operation. Since this is a minus 3x and I want the whole thing gone, I add 3x. Because what's negative 3x plus 3x? It would be 0x or 0. It's gone. What I do to one side, I have to do the other side. So I'm going to come over here and I'm going to add 3x to this side. Bring down what we have. The negative 5 comes down. These I can combine together and I get plus 1x, or just x. I have 3 technically plus 0. That's why we did it, right? The x's are now all gone there. And why do we like 3 plus 0? Because I can now add that together and just get 3. And now you'll notice we just have a very basic, simple problem from here. And now we just follow all the normal steps, which is to isolate the x value on one side. So I'm going to simply add the 5, not move the 5, right? I'm just making it disappear on the left side. So when I add 5 to this side, I'm left with x. And then, oh, by the way, since I added 5 over there, I also have to add 5 over there. So it looks like we're moving it, but in reality, we're making it disappear. And then I really am doing a poor job of reminding you to check your answers. But because it feels like an extra step, and we're all confident that we're smart and we do things right. But really, there is nothing stopping us from checking our work by plugging the 8 in and getting our answer, right? So let's just check this one real quick. Negative 5 minus 2 times 8 equals 3 minus 3 times 8. On this side, I get negative 5 minus 16, which I believe is negative 21. On this side, I get 3 minus 24, which is negative 21. The left side equals the right side. Everything is great. All right, let's move on. let's go ahead and have you do one on your own. So why don't you pause the video and do part A? It'll be very similar to the one we just did. All right, so we need to make a decision. And again, you can move or you can have the X disappear from either side. I generally try to plan ahead. Notice I said think before you act. I know that I am more likely to make a mistake if I get down to near the end of the problem and I have like a negative number X equals, because I'm going to forget to divide by the negative. So if I can plan ahead, I can think about what's going to happen. So, for example, I could choose to make this 3x disappear by adding 3x, the opposite, and adding 3x. But if I do that, now negative 5 plus 3 is negative 2x, right? There's nothing wrong with that. You will get the right answer if you pay attention. But if I can avoid it, I want to avoid having that be a negative, because most of my problems are going to happen right there. And you will notice that if I just make the opposite decision, and instead of making the 3x go away, let's move the 5x over instead. Or, again, said more properly, make it disappear on this side. So I'm going to add 5x to the right side, giving me a negative 7 plus 0, or negative 7. And now I combine my x's and I get 2x plus 5. The only difference here is now I have a positive 2x instead of a negative. The answer, I stress again, will be the same if you don't make an error. That's the whole point, though. I'll make less errors if I make sure I keep that positive. All right, now we just finish what we hopefully are getting very good at, which is just going through the motions to get x by itself, paying attention to the signs, negative 12. I am double checking all of my math as I do it, unless I get distracted by my own talking. Okay, so as I'm doing this, I'm spotting this negative and noticing a positive. I'm not saying it, but I am seeing it, and I'm really concentrating on making sure I don't screw up the most obvious thing I'll screw up. Okay, now let's go over to B. And this time, let's kind of analyze this together. And going back again to the first step, which is let's simplify both sides of the equation before we start worrying about anything else. So, in a way, we just sort of do the order of operations and treat each side as independent questions. So, I'm looking at the left side and I'm noticing that there is math to be done here. So, I am going to do that math. So, I'm going to go ahead and do the distributive property. I'm spotting that negative, I'm paying attention to it. I get negative 15x, or k, I guess. And I'm spotting this negative and that negative multiplied together make a plus. If I don't pay attention to it, I'm likely to mess it up. I still have this plus 3k. And then there's really nothing mathematical I can do on this side, so I'm just rewriting it. All right. Now we're kind of in step 2. Let's go look at step 2. Well, actually, I'm not quite done with step 1, am I? So I haven't fully simplified, because you'll notice on this line I just wrote, I have two k values. I've got this k value and that k value. And so I can just combine them together. There's no opposite stuff because I'm not removing one from one side of the equation. I've got a negative 15k, and if we just sort of, ignore that 30, it's negative 15 plus 3 k's. So when I add those together, I should get negative 12k. And I have the plus 30 still, and I still haven't done anything over here. All right, now I'm spotting and noticing I've got two different k values, so I'm moving on to step 2, which we can see at the top of the screen. Get the variable terms on the same side. So again, I'm planning ahead just to make my life a little easier, and I'm noticing that if I add 12k, as opposed to thinking about moving that 8, if I add the 12k to both sides, I put my variable on the right side, which in general I don't like, but what it does for me, though, is it makes sure that my answer, again, is a positive 4k here. Bring down the 34. Then I move the 34 to the other side, or said another way, I get rid of it on that side. And I'm left with a negative 4 equals 4k. So obviously when I now divide by 4, I get my answer. Feel free to at any point just switch things on the other side. Let's just rewrite it. So I get an answer of k equals negative 1. I'm going to write k equals negative 1 instead of negative 1 equals k. It's fine either way. But you can, if a equals b, right? A equals b, then b equals a. It doesn't matter which way you write it. All right. Just because you're a captive audience, or you can fast forward if you don't want to hear it, let's just approach this a slightly different way. Let's go back to this line, and let me just show you what I'm talking about here. Negative 12k plus 30 equals negative 8k plus 34. So I chose to move the 12k over last time, but let's do it the opposite way. Let's add the 8. Negative 12 plus 8 is the negative 4k, and that's what I was trying to avoid, is having that negative, but who cares? And then I get 34. I'm going to move the 30 over, and I get negative 4k equals positive 4. So the only difference in these two lines is that my negative, excuse me, my negative is on my variable, right? And my constant is positive. Here the constant was negative. But it doesn't matter, because when I divide by negative 4, assuming I remember, I'm left with k equals negative 1. It's the exact same answer. So it's not worth like 10 minutes of thinking about what should I do. Just move one. But if you're thinking about it and you're planning ahead, why don't you try to move it such that the result of that step is it's a positive k. And then you'll make less mistakes because you won't have this issue at the end. All right, if you know, you know. Let's move on. All right, I'll let you go ahead and try these on your own first, and then check back in, see how you did. Okay. Rule 1, step 1, simplify each side. Obviously, there's nothing happening over here, but I can do the distributive property over here. And I'm spotting this negative, and I'm paying attention as I do it. Negative and a negative make a positive. 4 times 6 is 24. All right, I got to get my ends on the same side. Now, since there's no constant on the other side, even if this result would be a negative n, what I keep talking about, I would still do this, because I would never want to move this n over here, because then I'm bringing the variables to the same side as the constant, and my goal is to get the variables by themselves. So I'll save myself a step by planning ahead and making sure I keep working forward towards our ultimate goal of getting n by itself. Negative n plus 4n is 3n equals 24. Now I have just to divide by 3. N equals 8. All right. On a side note, again, for those of you who are interested in learning everything, a lot of, especially at the early Algebra 1 stages, classic mistake happens right here. So let me scribble this in here. So if I'm at this stage, and let's say you make the mistake of moving this in over. So let's say you add into both sides. Okay? There's nothing wrong with that. It's an unnecessary step, and it makes it a little bit harder. But it works as long as you don't start making things up. What is negative n plus n? Some of you are going to say nothing, which is, I guess, sort of true, but what is nothing as a number? It's 0. We still have a 0 over there. We still have an equal sign. Now I have negative 3n plus 24. I can't tell you how many kids, if they make this mistake and move everything off the side here, will suddenly just decide to throw the equal sign like between these two numbers or something. You don't, like, I know some of you get a little confused with math, but I think it's because you think magic is happening or something. I'm literally doing what I say, and that's why what's important is when we show our work, we're showing it the right way. I'm doing the math that I see. I'm literally doing negative n plus n and figuring that out and realizing it's 0, and so I wrote an answer of 0. I don't just leave it blank, which some of you would do, and now I'm confused. And you see two things, and suddenly you want to throw like an equal sign between them. But there is no equal sign between them, right? There's a plus sign between them. So that's where we get into trouble with math, when we really just don't pay attention to those details. So if you had done that, we would have had 0 equals negative 4n plus 24, which just means we have an extra step. Here, I'm sorry, that was a 3n. Here, my variables, by choosing the right direction, my variables are separate from my numbers. Here, I have to move one of them back over. So I could like add the 3n back over. And I get 3n equals 24, and I'm where I was here. So again, why I said plan ahead, think before you act, and leave yourself in the best possible position to answer the question. And in general, that means never, ever, ever clean out a side because problems will ensue. All right, let's go ahead and get rid of all that and keep going. This is a pretty basic one. I'm going to move the 3x, get rid of that x over there, and I get 5 minus 3 is 2x. Still got my 6 and my negative 8, and now we're just at a really basic let's get our variable alone question. I am talking and focusing on the negatives all at the same time. I'm dividing by 2. I'm thinking about what I'm doing. I'm not in autopilot, and I get negative 7. Checking our work is a smart decision, but I don't want this video to go on longer than it has to, so I'm going to move ahead. All right, full disclosure, these are going to get a little weird. Let's pay attention as we go. Step 1, simplify each side. Nothing going on over here. Over here, I can do the distributive property. And what do you notice at this step? I hope that you notice that we have the exact same thing on the left side and the right side. 4x plus 6 equals 4x plus 6. Well, what was the goal, right? What are we trying to do? We're trying to find an x value that we can plug in to make this a true statement. At this stage in the game, if we're paying attention to what's happening, we should recognize that, hey, wait a minute, they're the same on each side. So if I plug a number in for x here, and I plug the same number in for x here, then I'm obviously going to get the same answer, regardless of the x value. This is what's known as an identity, because there's nothing I can do, there's no x value that would make it not a true statement. And so right away, I know that that any x value will work. So lots of ways of answering this question, but mostly we say something like, you could say all numbers work. You could say that there are infinite solutions is a very common way of answering this question. And I left out the ITE, infinite solutions. You could say all numbers work. What's another way of saying all numbers work? Remember we learned a couple weeks ago how to write numbers. You could say all real numbers, right? Everything works. Any of these answers would be acceptable. Now, sometimes it is a little more hidden at this stage and you're not really sure that you have the exact same answer. So let's just keep doing the math as if we didn't notice. Remember, my rule is to get our x's on the same side. So I'm going to take this guy and I'm going to subtract 4x on this side. And I'm going to subtract 4x on this side. And then that's weird because now, I was trying to make these x's go away, so I'm left with equals 6. But I wasn't necessarily trying to make these x's go away. I was just trying to get them on the same side, but that went to 0 also. So I'm left with 6 equals 6. I was expecting out of this an answer of x equals something, right? But I got an answer of 6 equals 6. Once again, what this is telling us is no matter what you plug in for x, you're always going to get it down to a true statement. And that is another clue that, hey, wait a minute, these are exactly the same and there's nothing I can do to change that. All numbers are going to work. Okay, let's contrast that with the opposite scenario. So over here, I'm going to, oh, by the way, let's just finish the loop here. You get down to here, this is not the answer. The answer isn't 6. The answer has nothing to do with 6. The answer we have to interpret. I can do math, but I can't talk and write at the same time. This is not the answer. The answer is this. So we would not get to here and put a box on this and move on. we need to interpret what this means, because a lot of kids will think that means the answer is 6 or something like that. No, all numbers work. So let's see what happens on this side. Nothing happening here, but I do have a distributive property. And let's kind of pause and stop at this stage right here. No matter what I plug in for x, at this stage, if I just stopped and I plugged in an x here and I plugged in x here, I'm going to have the same number as this one. Same number minus 5 equals the same number plus 8. Well, that's impossible, right? If I've got 4 minus 5, for example, and over here I've got 4 plus 8, like those aren't going to be the same number, and they never will. So right away, there is a big O hint that you probably won't notice, not right away, that no number is going to work. This is going to lead us to one that's going to have no solution. You have the same variable term on each side, but different constants. Here we had the same variable term and the same constant. But let's say we didn't notice and we keep going. Let's move this 6x over, and you get this, and you get negative 5. Hey, wait a minute, my x's canceled out again, just like they did over here, which makes sense because they're the same on each side. But now I don't get a true statement. I get this weird statement, negative 5 equals 8. No, it doesn't. That is not true. So what's happening here is we've said, hey, math, what x is going to work? And so we're doing our thing, and math's doing what it's supposed to do. But at the end, it doesn't know what to do. It can't give you the answer because there is no answer. There's no number I can plug in that will make this work. This is a situation where we have no solution. Okay? So to summarize, we've got this statement right here. When each side of the equation is identical, then any number, will be a solution. We call these an identity. It means that there are infinite many solutions, or that all numbers work. The biggest clue, again, is even if you don't notice they're the same at the beginning, because for some other reason it's hidden from you and you can't tell, or you're just not noticing it. But later you get down to 6 equals 6, or 5 equals 5, or some other true statement. In fact, if you're not paying attention, and we just went further and we subtracted 6 on both sides, we'd get a statement that said 0 equals 0. Still a true statement, right? So if that happens at any stage, you notice exactly the same, or exactly the same, this is called an identity, infinite solutions. Over here, same variable, different constant. You might not notice it here, but I hope you would notice it here because my variables disappeared. And that's weird, right? Usually I was expecting an x equals, x is gone. And I got a false statement. So weird and false versus weird but true. This means there is no solution. Nothing will work to make these the same. And if you didn't notice it here, you could have gone a step further and tried to add 5 to both sides, and that would have had like 0 equals 13, still a false statement. So most of us are hopefully going to notice it right there, that, oops, that tells me that there's no solution. I don't necessarily notice it here until I do my first subtraction. And about halfway through writing it, I'm like, oh, I see what's about to happen. Okay, that is it for solving equations on both sides. Obviously, the problems can be very simple, or they can be very, very complicated, much harder than what I've shown here. So we start with the basics and learn the steps. So please, please, please show your work. See you next time.